All right, excuse me, brothers and sisters, guys and goddesses. My phone died when I proceeded to, accidentally cut the video off. Proceeded to explain a bunch of stuff. Then my phone died, and I didn't get to save the video. So I'm gonna restart back where I was at. So we have what's being shown here is the AC power lines. Okay, you have one wire, the other wire. Okay. And then what you have is these solid circles, solid black circles, that's your magnetism, because magnetism creates space, okay? And then this line in the middle, okay, that's your inertial plane. That, like if you take some magnetic viewing film, that green stuff, and then you see the white line, same thing, okay? And then these dashed lines, that's the dielectric, your lines of tension. Okay. And then if we go over here, okay, to the electric field, all they show you again is those lines of tension. That's all they show you. But if you understand that electricity is the conjugation, the hybrid, the offspring, the lock and key, the male and female nature, okay, how they fit together, do you understand? Once you have those two things, then you get electricity. Dielectricity plus magnetism equals electricity. What is it? 5 times psi equals the Planck of electrification squared. But it sounds like I'm just spewing bullshit. But so yeah, that's all they show you is the electric field. But then the magnetic field, they show you the torus. So you're just looking at it like this, and in this view, I'm like, man, like that's a hyperboloid, because they're the same thing, and it's just the way I'm viewing it. They're the same thing. Okay, it's the hyperconnectivity of everything. Okay, the incommensurability, which just means fractals. Okay, it's the easiest way to understand it, and I struggled with it for a long time. And then once I realized, oh, it's just fractals, that made everything so much simpler. So if anybody's ever heard that word, and it's like an ancient metaphysical word, and if anybody's ever struggled with that word, that's basically just what it means. Okay, but you know, kind of forgot some of the things I explained, and just kind of want to go over this quickly because the other part of this video is 22 minutes long, so I'm just kind of trying to wrap this up. But if you look at a magnet, okay, the iron filings of a bar magnet, they show you these lines of tension. Okay, so they don't even understand what they're looking at. Okay, because oh, this is the magnetic field. No, this is lines of tension from the dielectricity, because a magnet is all right. This is a magnet, the definition of a magnet, not magnetism, but a magnet, okay? Like this, or like that big honking powerful thing down there, okay? A magnet is a incommensurate point source electrified dielectric object. Okay, now what does that mean? Every single one of these atoms, okay, and this North Pole and in this South Pole. In the North Pole, they're all acting as one large atom. It's a multiplicative effect. They're acting as one large magnet emanating from one source. And manifesting from one source. Emanating isn't the correct word. Manifesting from one source. Okay, and it's the same everywhere. If I were to cut this out, cut a piece off. This piece contains the exact same information as this whole magnet. Okay. Now, electrified, because in order to create a magnet, what's the most common way? Charge up capacitor banks, discharge all of that, because then discharge all of that into a copper coil, which creates an electromagnet when you discharge the coils, which creates a super strong magnetic pulse and aligns every atom. Okay, and so it's electrified. And dielectric is because, well, not necessarily, but generally speaking, I guess you can even say you have diamagnetic objects in there, but so that's the definition of a magnet, right? So they don't even understand that they're showing you, when you see a magnet, you're seeing dielectricity, but then when they show you a electromagnet, you're seeing the torus. You're seeing actual magnetism versus dielectricity. These two things combined create the electric field, create electricity. Okay, so dielectricity, and again, dielectricity is just static electricity. I could prove that to you by, easiest way is if I were to cut up a bunch of styrofoam into small enough pieces, with this magnet or this big honking thing, okay, one of the strongest magnets in the world, I could hover it over some styrofoam and watch it all attract like it's metal. And styrofoam is what? A form of plastic. So it'll attract anywhere on this magnet. Okay. Dielectricity is static electricity. Again, everything's being covered up. So that's kind of one way I want to show you, and then I want to show you, since I don't have my ferrocell built correctly, I want to show you a magnet on the tube TV and show you this dielectric counterspatial vortex sink, whatever you want to call it. Whether you want to call it the dielectric portal to counterspace the inertial plane, whether you want to call it a counterspatial sink, a null point, 0 point vortex, whatever you want to call it. Like Shakespeare said, even though fuck Shakespeare because he was King James, he said what? A rose by any other name is just a sweet. So it doesn't matter what the fuck you call it. What matters is your comprehension of the principle. So we're going to turn on the good old tube TV, and if I hold it nice and close, magnets will vibrate. Just like if I were to turn on this, which is a motor, it's a rotating field generator, so magnetic fields just spin around in there. Okay, if I were to take a magnet, a spear magnet, it'll go around in a circle, just like an induction motor would, because that's what it is. It just doesn't have a load on it, and then the magnet will vibrate as well. So yeah, turn the TV on, feel it vibrate a little bit. Okay, and that should tell you the shit that's going on is fields, not particles. But boom, what do we see here? Hyperboloid. Okay. So you see we have this big black spot. Why is that? Because we have magnetism, okay? This toroid shooting out into space. And what's coming out of this tube TV is not electrons. It's dielectric lines of tension being snapped, okay? So there's a bunch of, and we all know, like I said, dielectricity is static electricity. And what do you hear right now? What does everybody know a tube TV for? It's static electricity. So I put this here, and magnetism and dielectricity hate each other, okay? Because one's counterspatial, the other is spatial, okay? So I get this big black spot because the magnetism is displacing the dielectricity. But you notice there's one spot in the center that's white. And depending on which way you have the magnet, there's these little hairs, okay, that will rotate in different, like say I can't see it, but I don't know what pole I'm dealing with, but say right now it's rotating this way. If I flip it, now it's rotating this way. But why is there a white spot there? Because that's the dielectricity, okay? And it's not being displaced because magnetism doesn't exist here in the center. And most of us deal with magnets that are this size or smaller. And this is 1 inch. So most of us are dealing with magnets that are smaller than this. And if they're bigger than this, chances are they're a lot weaker. Probably ferrite. Okay. Whew. But you don't get that because there's no magnetism here to displace that. It's dielectricity. Okay. So that's why you get the white spot. It's attracted to that spot. Okay. And then if this magnet was a 1x1, if it was just one magnet, you would see that this shape here is a perfect egg. And I have a 1x1 around somewhere, but I don't feel like going to look for it because I've already tried and I can't find it. And a 1/2 inch by 1/2 inch N52 is not strong enough to do this. But you can see, okay, you can see our toroidal field, okay? And then you can see our hyperboloidal dielectric field. And same thing, it's just depending on how you look at it, okay? But yeah, so you have two different things. And now, real quickly, just to prove to you even more, what's my